All right, we're ready to begin activity 4-2, which is called Row Game, Solving Equations Practice. Ooh, it's a game. Fun, right? Okay. The directions state, solve the equations in one column. Your partner will work on the other column. Check in with your partner after you finish each row. Your answers in each row should be the same. If your answers aren't the same, work together to find the error and correct it. Okay, so we are working in isolation here, so we're not going to be working with other students as partners. So what's going to happen is you are each going to be partner A, and I am going to be partner B. And we'll have you solve these and submit your solutions before we go over each one. But first of all, I just want to, if you look at these, even though the equations are different in the in each row in the columns, the equations are structured the same. So, for example, problem A, in column A, you have 18 equals 2x. The corresponding equation in column B is 36 equals 4x. So in both of these, you've got a number is equal to a multiple of x. In B, you've got a number is equal to x plus some number. So this way, even though the numbers are different, the equations in each column are going to be solved similarly. And the other thing, let's take a look at this. Now, we solve equations by trying to get our unknown quantity on one side of the equal sign all by itself. That was like trying to get the unknown weight all by itself on one side of the hanger. And solving the equations is really just the same thing. I want to get 1x. All of these use the variable x. I want to do whatever I need to do to both sides of the equation so that I am left with an equation that just has 1x on one side of the equal sign. But again, and I can do whatever I want as long as I do the same thing to both sides of the equal sign, because then I still have a true equation. I still have a balanced equation. So before you get started, if we just look at this, you have 18 equals 2x. You want to get x all by itself, so you need half of that. So you're going to divide this side by 2. And then you're going to divide the left side by 2. In B, you're adding something to x. You've already got just 1x, which is good. You don't need to multiply or divide, but you need to get rid of this plus 9. So you would subtract 9 from the right side, but then you need to subtract 9 from the left side. So in each of these, you're always doing whatever you need to do to both sides of the equation to get x all by itself. Now, if we look at D, it's a little bit trickier. You don't have 1x, but it's not a matter of dividing by a whole number. You don't even have one whole x. So what I want you to, I just wanted to remind you of this, is that if you take any fraction, so let's say 2/3, and you multiply it by its reciprocal, you flip it over, you get 1. So in equations such as this one, where you don't have a whole number multiple of x, but a fraction, what you would want to multiply by to get a whole number x would be the reciprocal of the fraction. So in this particular equation, I'd want to multiply both sides by 4 over 1. And I'd have to multiply 21 by 4 over 1, which is just 4. All right, so let's get started. What I'd like you to do right now, and you should have some scratch paper to work on, is I would like you to solve equation A and submit your answer. And meanwhile, I shall be over here solving equation A in my column. Okay, get started. Okay, so for equation A in my column, let's use a darker pen. I want just 1x. I've got 4 x's. So I'm going to divide that by 4, But then to keep my equation balanced and keep it a true equation, I have to divide the other side by 4 as well. 4 divided by 4 is 1, so that leaves me with 1x on the right. And on the left, 36 divided by 4 is 9. And there's my solution, x equals 9. So that should be what you got here as well. If you divided both sides by 2, you should have gotten 9 equals x. Okay, go ahead and do problem B and submit your answer. And I am going to do problem B in my column. Okay, problem B, I have 1x already. There's no coefficient here, so that means it's just 1x. But I want it all by itself on one side of the equal sign, so I need to get rid of this 5. It's being added, so to get rid of it, I'm going to subtract it. But to keep my equation balanced and true, I need to also subtract 5 from the left side. So on the right side, 5 minus 5 is 0, and I could write 0 here, but it's not necessary. But I still have just the x all by itself now on the right side, and on the left side, 13 minus 5 is 8. So that should be your answer as well. In your equation, you needed to subtract 9 from both sides, and you still should have gotten x equals 8. All right, go ahead and do problem C and submit your answer. And I am going to do problem C in my column. All right, I still want to just get x all by itself on one side of the equal sign, but I've got 3 of them. So to get only 1 by itself, I need to divide by 3. That means I need to divide by 3 on the other side as well to keep my equation true and balanced. So 3 divided by 3 is 1, so that leaves me with just 1x on the left, and 21 divided by 3 is 7. So my solution is x equals 7. That should have been your solution as well. For your equation, you would have divided both sides by 8, and that would have left you with x equals 7. All right, go ahead and try and do problem D in your column and submit the answer. And remember, you're trying to get 1x. So you have to figure out, how do I make 1/4 into 1? And that's what I talked about, multiplying by the reciprocal, wink, wink. Okay, go ahead and do that problem and submit your answer. All right, so here, my problem's similar to yours, except instead of 1/4 x, I have 1/3 x. And I'm still trying to think, I want just 1x. So I have to think, what do I have to do to 1/3? What would I have to, if I have 1/3 of x, how do I get 1 whole x? And that would be multiply by the reciprocal, which in this case is 3 over 1, or just 3. So I'm going to multiply both sides by 3. And this is how I like to show multiplying both sides by 3, putting the expression inside parentheses and then putting the multiplier next to it. So 3 times 1/3 is just 1, so that leaves me with 1x. Now 3 times 28, I'm going to do this in my head. 3 times 8 is 24, and 3 times 20 is 60, and 60 plus 24 is 84. So my solution is x equals 84. In the one you did, you had 1/4 x, so you would have needed to multiply both sides by its reciprocal of 1/4, which is 4. So on this side, 4 times 1/4 is 1. You'd get 1x, and on this side, 4 times 21 is 84. All right, go ahead and try problem E and submit your answer. All right, problem E on mine, I have 8 times x equals 60. Again, I just want 1x, and I've got 8 of them, so I'm going to divide by 8 on the left side, but then I must also divide by 8 on the right side. So on the left side, 8 divided by 8 is 1, so that leaves me with just 1x. And on the right side, 8 does not go into 60 evenly. So if I do 60 divided by 8, I'm going to end up with a mixed number. And I could set this up as a long division problem. But for me, it's easier to just look at this as being an improper fraction and just simplify it. So 8 goes into 60 7 times. And 7 times 8 is 56. 60 minus 56 is 4. So the remainder is 4/8. And then I would simplify that to 7 1/2. So the answer should be 7 1/2. So in your problem, you have 6x. To get 1, you have to divide by 6. You divide 45 by 6, and you should still get 7 1/2 as your answer. All right, let's move up to F. Go ahead and do problem F. This one is going to require you to do subtract a mixed number. But think about what we did in the warm-up. You could do this mentally by first subtracting the 4 and then subtracting the 5, 6. Anyhow, go ahead and try that problem and submit your answer, and I will do mine. Okay, my problem was x plus 3 5/6 equals 8. So I've already got 1x. I don't have to multiply or divide that by anything to get 1x. But I do need to eliminate this 3 5/6 from the left side of the equation. So I'm going to subtract 3 5/6 from both sides. When I say both sides, I mean both sides of the equal sign, not both sides of an expression. All right, so 3 5/6 minus 3 5/6 is 0. So on the left side, that only leaves me with the x. And then on the right side, I'm going to do this by parts. 8 minus 3 is 5. And then 5 minus 5/6, I know 1 minus 5/6 would leave 1/6. So 5 minus 5/6 is going to leave 4 1/6. If you have issues doing this in your head, you can go ahead and do the calculations like we were working on paper during Delta Math. But this is one you should be able to do in your head probably. Okay. So in your problem, you would have needed to subtract 4 5/6 from both sides. 9 minus 4 is 5. And then 5 minus 5/6 is again going to be 4 1/6, similar to my problem. Okay, go ahead and do problem G and submit your answer. And I'll work on mine. Okay, problem G might look a little intimidating at first. Your goal is always to get 1x by itself on one side of the equal sign. But you need to remember what we talked about with reciprocals. So if I want to multiply 3/7 by something to make this into 1, I would multiply by its reciprocal, 7/3, because that gives me 21 over 21, which is equal to 1. So I am going to multiply both sides of this equation by 7/3. And this is how I like to represent it. I put the expression inside parentheses and then the multiplier outside of it. So I need to multiply 33 by 7/3 as well. Okay, so 7/3 times 3/7 is 1. So I just have 1x now on the left. And then the right, I have to do 7/3 times 33. But this isn't that bad. If you think about it, if I write the 33 as an improper fraction, I can see that 33 and 3 can both be divided by 3, so that simplifies. And 11 times 7 is 77, and 1 times 1 is 1. So I have 77 over 1, or just x equals 77. So for your equation, your reciprocal that you would want to multiply both sides by is 7/5. And then 55 times 7/5, you would get the same answer. You'd end up with 11 over 1 times 7. All right, go ahead and do problem H and submit your answer, and I will do my problem H. All right. So here, again, I want to get just 1x. I've got 10x, so I need to divide this by 10 to get just 1x. So I'm going to divide this side by 10. That means I must also divide this side by 10. 10 divided by 10 is 1, so I'd have just x on the right side. And now I've got to do 1/3 divided by 10. And I'm going to just do this at the top of my paper. This is 1/3 divided by 10. So I'm going to write that as an improper fraction, and instead of dividing, I'm going to do keep, change, flip. So I get 1/3 times 1/10. So I get 1/30. And that is my solution. So sometimes your solutions are going to be nice, neat numbers. In your problem, you would have divided both sides by 6. So you would have had 1/5 divided by 6, which is the same thing as 1/5 times 1/6, and you still would have gotten 1/30. All right. Okay, we're getting close to the end. I know this is a long activity. Go ahead and do your problem I and submit your answer, and I will do mine, and we will check our answers. All right, so I already have just one x on the left side of the equation. I just need to eliminate the 6.17. This is positive, so to get rid of it, I am going to subtract 6 17/100 from both sides of the equal sign. All right, so on the left, this is easy peasy. I'm just left with x. On the right, now again, this is kind of going back to what we did in our warm-up. I can do this mentally. I don't have to. I could do it, pencil and paper. But I know 9 minus 6 is 3. 3 minus 1/10 would be 2 9/10, or 2 90/100. And 2 90/100 minus 7/100 would be 2 83/100. Do you have to do it that way? Heck no. You could do 9.00 minus 6.17. You can't do 0 minus 7, so you're going to borrow. And that becomes a 9. That becomes a 10. 10 minus 7 is 3. 9 minus 1 is 8. 8 minus 6 is 2. So in your problem, you would be doing 5 minus 2 17/100. But you should get the same solution, x equals 2 83/100. All right, go ahead and do problem J. I will do mine. Submit your answer, and then we'll compare. All right, here we go. This is another one of those where I don't have 1x. I have 7/15 of x, and I want 1x. So to get 1x, I'm going to have to multiply this by the reciprocal of 7/15, which is going to be 15/7. And then I need to multiply the left side also by 15/7, because I want to keep my equation balanced and true. So on the right side, this is easy. 7/15 times 15/7 is just 1, so I have 1x. On the left side, I can do some simplifying before I multiply. 14 and 7 can both be divided by 7, so 14 divided by 7 is 2, 7 divided by 7 is 1. 15 and 5 can both be divided by 5. 5 divided by 5 is 1, 15 divided by 5 is 3. And now, this is fairly simple. 3 times 2 is 6 over 1 times 1, and 6 over 1 is just equal to 6. So my solution is x equals 6. So in your problem, you want to get x all by itself. It's being multiplied by 10/9. So you know to get 1x, you're going to have to multiply it by the reciprocal, which is 9/10. And when you multiply this side by 9/10 and do the simplifying, you would still end up with an answer of 6. All right. So I just want to recap. All of these equations involved either adding or subtracting something from both sides, or multiplying or dividing both sides by some number. And they were really only two types of structures. You either had x being multiplied by a number, or x being increased by a number. So if you were adding something to x, you solve the equation by subtracting that something from both sides. If x was being multiplied by a number, you solved it by dividing both sides by that number, or multiplying by the reciprocal, either way. All right, we're good. That was a long activity. You might need to take a break.